Welcome to today's tutorial on object detection in video. I will go over a code to perform this step by step using Python. I already created a script, a .py script called object detection, where I will start coding from scratch. You can open this in any editor you like, but I'm using Sublime Text, which is my favorite. So first I will start by importing the OpenCV library, which is the only library we'll be working with. And then what we'll do is read our video and call it capture cap cv2 video capture, and the file is called vtest avi.mp4. So what this line does is reads video from file. Next we're just gonna get some information on the frame width and height and put that as an integer. And there's a function within OpenCV which is called get, and then we put in the argument cv2 get prop frame width. And this line of code here, get frame width as an integer. And we do the same thing for height. I'm just gonna copy paste because I'm lazy. And then instead of having width here, we have height. And again, this one gets frame height as an integer. Next we're going to construct the 4cc code of the codec to be used here. So just name it 4cc, and that also comes from the OpenCV library. And there's a function called video writer underscore 4cc, and then you just give it the 4 character code here, xvid. So construct codec to be used. In the constructor. Next we're going to get the video writer class, again from OpenCV, called, there's a function called video writer. And so we're gonna give it the file name to write. Trying to get the double, yeah, there you go. And we're just gonna name it output.avi, just in AVI format, and I give it the 4cc codec, and then we give it the frames per second, the frame rate 5.0, and the frame size. So we're just gonna have it as 1280 by 720. So this is the frame resolution. So get video writer class. Then we're going to read the video frame from our video reader cap.read, and then we will do the same thing for what we call frame 2 that we will use later in the code. So it's just to keep it duplicate, really, of have two frames, that frame 1 and frame 2, to use later in the code. We can do a print if you want to see that on the frame 1 the frame size. So frame 1.shape. Now we're going to do the processing for the object detection here. So we start with the while loop. So while cap is opened, so this function checks that the video capturing has been initialized. So while this is always true, we're gonna perform some operations on the frames. So first we're gonna take the difference between frame 1 and frame 2, or the absolute difference. So there is an OpenCV function called appsdiff, and we'll give it the two arguments here. Sorry, frame 1 and frame 2. So this one, as I said, calculates the difference. So it's the per element, because there are essentially two matrices, to element absolute difference. So you calculate the difference per element and then take the absolute of it between two frames, or frame 1 and frame 2. Next, what we get effectively is just another matrix. So we will convert that to grayscale and use the CVT color function. And so as input we get the difference frame, and we specify the color that we would like to convert. So it would be color PGR to gray, and these are all documented in OpenCV library. So here is just convert to grayscale. Next we will add some Gaussian noise to the frame, which is effectively blurring an image in like image processing. So we just create a new variable called blur, and again on OpenCV there is a function called Gaussian blur, so it would be Gaussian noise that we are adding here, and we'll add it to our previous or latest frame, which is gray. And then so this is the kernel size, height and width 5 by 5, and we'll give it a 0 standard deviation as a parameter. So this adds Gaussian noise. Then next what I'm going to do is just threshold the frame, and so just doing this in underscore just for the first parameter that the function we will use returns, and what we're interested in is the thresholded output. So that's why we're ignoring the first returned parameter and we're just keeping the threshold ones. So we use the function threshold, and we will use blur image, and then here I'll explain these input arguments shortly. So 45 CV2 fresh binary, right? So the first argument that this function takes is first is the input, the frame that we will threshold. Then these values are in pixel, so this 20 is our threshold value and 255 is the maximum value. And then the last parameter here is just the type of thresholding, which is binary here. Then our next processing will be to do some frame dilation to increase the white region or foreground in the image. So we'll create a frame called dilated, and we use an OpenCV function again, which is called dilate. And we give it as input our previous output here, fresh, and then give it other arguments, iterations equal 3. So these are just default input arguments. Next we will find the boundaries of the same color or intensity in the image, and this will be done by using a function called find contours. So sorry, contour, and we ignore the second parameter it returns, and the function is called find contours. We give it as an input our dilated frame, and then so we give it the contour retrieval mode, and then the control approximation method. So for the contour retrieval mode, it will be a tree type, and then for the second argument, the approximation is a chain approximation. So it's chain approx simple. Sorry, I forgot to comment the previous lines. So this is threshold. And this one is frame dilation to increase the white region or foreground in the image, mainly foreground. And then this one is to find boundaries of the same color or intensity. Okay, next what we will do is iterate over the contours to get rectangle coordinates, and that what we will use to draw rectangles over the objects in the image. So be for contour in contours, we will get the coordinates, so x, y, and then width and height, and we will use a function called bounding rect. Then we will add this loop to skip the iteration if the contour is less than a certain value. So we do if contour area is less than 900. What we'll do is do a continue on the loop just by skipping what will come next, which is get draw a rectangle on the frame. I keep forgetting to comment the code here. So this is to get rectangle coordinates. According to region of interest. and here we will skip iteration. Then we will use the rectangle function and to draw a rectangle on frame 1 using the coordinates that we extracted up there in line 29, which is xy, and then x plus the width and y plus the height. And we'll just give it the pixel values 0 to 155. I will comment this again. Draw a rectangle on frame. And then we will add some text using the function put text frame 1 and this will be the text that we will write. Status format. And then we just specify the font that I would use for the text. So font, we'll just use the Hershey Simplex. Yeah, so these are all documented with the specific functions in OpenCV library. The font Hershey Simplex, for example, the approximation method, etc. This is write text on frame 1. Oh, and also need to put in some pixel values, coordinates, etc. So 0. Yep. Okay. Next we will prepare our image to be outputted. So we'll resize the frame and put that in a variable called image. PCV2.resize frame 1, and again we give it the frame size that we want to resize to, so 720, and this is according to the resolution that we specified in the video writer. It's consistent. So this is just a resize frame, and then we write the frame to video writer class, which we called out previously here, and we use the function write, and we write the image. Write frame to video writer class, and then we will do a show on that video using the function image show from OpenCV. Give it a feed, and we want to show frame 1. And then we set a new frame, so frame 1 equal to frame 2. Now what we'll do is grab decode and return the next video frame. So same as earlier, do cap.read. And grab decode and return the next video frame. Now I will wait for a keyboard event using this function called waitKey, and we would wait for 40 milliseconds for the 27 is the escape key to be pressed. Let's wait for 40 milliseconds for a keyboard event, and that is the escape key. And what we'll do here is just break the code for the while loop from running and stop the video capturing, and then we will just close video files or any capturing. First we use the OpenCV function called destroy all windows, and then close the video reader and writer, so cap and out that we defined previously up here in the code. So line 4 and 11. Yeah, I think that's it. Now I will just test the code. I run this from the terminal and on Anaconda, where I have the Python environment, the Python package installed, and in the environment that I created called test, and I also have the OpenCV package installed as well. So what I will do is run it using this command line, Python object detection.py, and of course I'm in the right directory as this file here, where my video file is as well. And so first we got a print of the terminal of the frame shape from this line here, and we can see the feed here of movement. So this is the text that we put on the frame, status movement, and the movement tracking using the object detection. Now if I press the escape key to test that line 44, then it stops. Yeah, I think that's all. I hope you enjoyed this. Thank you for watching.